Hello everyone, welcome to this presentation. My name is Richard Adute. This presentation is on the 4 to 1 multiplexer, also known as a MUX. This is part of our computer architecture assignment, and I'll be explaining what a MUX does, how it works, and its truth table in the simplest way possible. Some might ask, what is a multiplexer? A multiplexer is a digital device that selects one of several input signals and forwards it to a single output line. It is controlled using select lines which determine which input to forward. Multiplexers are often called data selectors. Okay, so introducing the 4 to 1 multiplexer, which we'll be covering in this presentation. Yes, this MUX has four input lines: I0, I1, I2, I3. It has two select lines, S0 and S1. The select lines determine which input is passed to the output. Logic gates like AND, OR, and NOT are used to build the circuit. This is how the internal logic diagram of a 4 to 1 multiplexer looks like using basic logic gates. So explaining how the circuit works. The NOT gate inverts the select lines S0 and S1. Then the inverted signals go to the AND gate, which with each input I0 to I3. Okay, only one AND gate outputs a high signal based on the select line combination. The OR gate combines all AND gate outputs and forwards the selected input to the output. The below diagram shows the truth table of the 4 to 1 multiplexer, also known as MUX. Okay, so with the truth table, each truth table shows how the select lines S1 and S0 determine which input from I0 to I3 is connected to the output. Okay, so when S1 is equal to 0 and S0 is equal to 0 2, the output is going to be I0. This is because only the AND gate connected to I0 and the NOT versions of S1 and S0 is active. Secondly, when S1 is 0 and S0 is 1, output is going to be I1. This is because the AND gate with I1, not S1, and S0 is activated. Thirdly, when S1 is equal to 1 and S0 is equal to 0, the output is going to be I2. This is because the AND gate with I2 and S1 and not S0 becomes active. Lastly, when S1 is equal to 1 and S0 is equal to 1, output is going to be I3. This is because the AND gate with I3, S1, and S0 sends its signal to the output. All other AND gates stay off, so only the selected input reaches the output. These are some applications of multiplexers. Multiplexers are widely used in 1. Data routing in processors and memory units, signal selection and communication systems, simplifying digital circuits by reducing wiring, and lastly, control systems where multiple signals are managed by one line. Okay, so to summarize this presentation, we first spoke about the 4-to-1 multiplexer, which selects one of four outputs based on, sorry, which selects one of four inputs, not outputs, inputs based on two control lines. Also, we said it uses combinations of AND, OR, and NOT gates. Only one input is sent to the output at a time. Lastly, this design is essential in digital and communication systems. Thank you for watching and have a great day. Bye bye.